From the very beginning, 3i Atlas defied expectations. Comets, especially interstellar ones, tend to appear as soft, diffuse objects in the sky, glowing clouds with undefined edges, surrounded by expanding halos of dust and gas. Their structure is chaotic, born from sublimation and fragmentation as solar radiation erodes the icy surface. But on the morning of November 29, 2025, a series of synchronized observatories captured something that shattered that framework, a sharply defined object with visible boundaries, geometric symmetry, and no evidence of random dust dispersion. It began with thermal and optical images taken within minutes of each other. ESA's Deep Space Thermal Imager revealed a bright, stable core with surrounding heat signatures that remained confined. No streaking, no flare-out. Then, nearly simultaneously, the ground-based Gran Telescopio Canarius and Pan-STARRS observatories released high-resolution visual overlays. What they saw forced a re-evaluation of the entire observation sequence. The core didn't fade into the surrounding space like most comets. It stopped, cleanly, a sharp cut-off in luminosity, a sudden edge. This sharply bounded light signature was unusual enough, but as data came in from telescopes in Chile, Norway and Hawaii, a second observation deepened the mystery. The sharp shape was consistent from every angle. Normally, a comet's coma appears asymmetric based on the observer's position relative to the Sun, a natural result of jets firing in different directions. But 3i Atlas maintained a shape that was not only stable, but uniform across multiple angles of observation. This ruled out a temporary flare or dust shadow. It meant we were seeing the actual body, not just a surrounding haze. Shape modelling was the next step. Using angle-specific brightness drop-offs and spectroscopic reflection data, astrophysicists attempted to reconstruct the surface geometry. What emerged was deeply strange. Not a sphere, not a blob, but something with flattened planes. The object reflected light in a way consistent with faceted symmetry, perhaps hexagonal or even trihedral, but the angular transitions were too abrupt for any known natural comet. One model suggested an oblate body with 6 converging ridges. Another proposed a set of reflective panels rotating in sequence. But none of the outputs looked remotely organic. Still, skeptics were quick to raise flags. Could this be a stacking artifact? An error from overlapping exposures or CCD lens flaring? But those possibilities evaporated when the same shape appeared in infrared. Thermal data doesn't lie in the same way optical reflections can, and in the thermal readout, the object still displayed an abrupt temperature cutoff at the same angular points where light intensity dropped in the visual band. This proved the edges were real, not noise, and more importantly, they were physical. Then came perhaps the most shocking discovery, when, animated across the pulse rhythm of 9.04 minutes, the same timing tied to previous emission patterns, the edges of the object expanded and contracted with millimeter-scale regularity. The glow didn't blur, it breathed. Like a mechanical iris or expanding lens, the outer boundaries fluctuated just slightly, maintaining full symmetry even during motion. No comet on record has ever exhibited such organized motion at the edge of its structure. It wasn't turbulence, it wasn't erosion, it looked controlled. All of this led to one unavoidable conclusion. Something about 3i Atlas is preserving its shape, deliberately or inherently. Whether this is a result of unknown physical properties, advanced cohesion in its material makeup, or something more deliberate, we do not yet know. But the first rule of natural behavior, that heat and radiation dissolve shape into chaos, does not apply here. This object is retaining form under stress, and for scientists across 5 continents, that was the first true warning. Because nature can form complexity, but it very rarely maintains symmetry under pressure, and when it does, it's usually called structure. The second anomaly that raised alarm on the morning of November 29, 2025, was something so precise, so strikingly organized, that for many researchers it became the moment they realized 3i Atlas was no longer behaving like any natural body we have ever catalogued. Across multiple instruments, optical, infrared, ultraviolet, and even radio band reflectors, scientists observed something that simply should not exist around a comet. 3 perfectly persistent rings surrounding the core, spaced with mathematical regularity. The discovery emerged initially from thermal readings, ESA's infrared survey had been tracking the heat gradient around 3I Atlas for days, expecting the usual diffuse spread caused by sublimating ice and escaping gases. But instead of a gentle gradient, the thermal profile showed 3 discrete layers of elevated temperature. These were not random blobs of activity. They were clean circles, each forming a continuous band around the core. Even stranger, the temperature between the rings wasn't transitional. It dropped sharply, then rose again, forming a pattern reminiscent of stratified atmospheres or engineered shielding layers. When the thermal data was overlaid with optical images, the shock deepened. In ultraviolet light, the same rings appeared as faint luminous halos. They didn't fluctuate wildly like plasma storms or dust jets. They held their thickness, brightness, and radius within margins that were so precise they could only be measured in fractions of a percent. Each ring was spaced 11 kilometers apart from the next, an interval so consistent that it immediately ruled out natural dust motion. Dust does not position itself at equal distances. It drifts, collapses, or expands chaotically. Yet these rings were not drifting. They were staying exactly where they were, as if something held them in place. The first reaction from NASA's analysis teams was to assume interference. Could these be diffraction artifacts created when light interacts with the surrounding dust field? Could the rings be echoes from instrument optics? But this possibility disappeared as soon as multiple independent telescopes confirmed them, including ground-based observatories that used entirely different sensor designs. If the rings were artifacts, they would not have survived cross-instrument comparison. Next, the idea of magnetic confinement was proposed. Perhaps the object was interacting with the solar wind in a way that formed standing waves or spiral patterns. But when magnetometer data from the solar orbiter was compared to the ring spacing, there was no match. The rings did not align with magnetic field changes, nor with ion density waves. And more importantly, the rings rotated with the object, even though the surrounding plasma did not. They were locked to the core, not the environment. The most unsettling clue came when radio frequency reflectors were aimed at 3I Atlas. A faint but consistent echo returned from the boundaries of each ring. This meant they were not merely regions of differing temperature. They had physical density, capable of interacting with electromagnetic waves, and the spacing between the echoes matched the same 11-kilometer interval. When James Webb re-examined the rings using near-infrared spectroscopy, another anomaly emerged. Each ring had a different spectral signature. The innermost ring showed high-energy infrared scattering consistent with heated particulate matter, something like ionized dust. The second ring produced a weaker, colder profile, but with a smoother spectral slope, almost like a thin layer of condensed material. But the third ring, the outermost one, had the strangest data of all. It reflected light with a consistency that suggested uniform particle size, as if the entire ring was composed of material filtered to a single grain dimension. Nature does not filter particles by size and place them in perfectly spaced shells around an object. Yet here, that is exactly what scientists were seeing. Even more concerning was the stability of the rings. From the moment observatories began recording them, their radii never drifted more than a few meters. Comets do not produce stable structures. Asteroids do not produce layered emissions. Plasma fields do not maintain radial symmetry for hours on end. But on November 29th, 3I Atlas did. As the rings persisted throughout the morning, one interpretation rose quietly among analysts, not spoken publicly, not written in official memos, but exchanged in private conversations between researchers who understood what the data implied. 3 rings, 3 layers, 3 perfectly stable distances. Layering is not the behavior of a chaotic body. It is the behavior of a system. By the time global observatories completed their synchronized thermal sweep of 3I Atlas on the morning of November 29th, 2025, a third anomaly emerged, one that defied not just expectations, but the foundational principles of thermodynamics. It wasn't the presence of heat. It was how that heat moved, not randomly, not radiating outward from a central point like it should in a natural body. Instead, it followed a path, a repeating one. It looped. At first glance, the heat signature of 3I Atlas appeared irregular, perhaps even unstable. But when analysts overlaid the full set of thermal images collected from the James Webb Space Telescope, ESA's solar orbiter, and multiple ground-based infrared instruments, something became very clear. The hottest zone on the object's surface shifted position in a clockwise direction, forming a continuous arc that completed a full cycle every 9.04 minutes, the exact duration of the now familiar emission pulse linked to the object's internal activity. This heat migration was not a glitch. It was measured, quantified, tracked across 4 separate orbital passes, and confirmed by at least 3 high-altitude balloon observatories over Chile and Australia. The shift wasn't atmospheric distortion. It wasn't instrument lag. It was real motion, a hot zone migrating around the object's equatorial line with clockwork precision. To be clear, no known comet, asteroid, or natural interstellar object has ever demonstrated this kind of behavior. In natural bodies, heat tends to accumulate at sun-facing surfaces and slowly radiate outward. If rotation is involved, thermal zones stretch and smear over time, forming blurred gradients. But in the case of 3I Atlas, there were no gradients. Instead, the thermal readings snapped from one high zone to another, forming a clean circle of movement. It was as if the heat wasn't simply radiating, it was being delivered. And that changed everything. If the object were rotating, one might argue that the hot zone simply follows the sun-facing side. But that theory fell apart immediately. 3I Atlas's axis of rotation had already been established from earlier light curve modelling, and the direction of the rotating heat loop didn't match it. In fact, it moved independently of the object's known rotation vector. The conclusion? The thermal motion was internal, not caused by surface spin. This distinction matters. A body that moves heat internally in a predictable, repeating pattern must have some mechanism for that motion, and this isn't theoretical. NASA's own modelling of the looped heat path revealed a sequence that closely mirrors closed-loop heat transfer systems used in engineered spacecraft. Systems designed to absorb energy in one zone and carry it elsewhere in order to manage surface temperature under extreme conditions. The spacing of the moving hot zone also lined up suspiciously well with the shape of the rings identified earlier. As the internal heat loop passed near each of the 3 concentric energy bands, those rings showed minor spikes in brightness, as if the passing thermal current was activating or interacting with them. This interaction was so consistent that it created a secondary rhythm in the energy field around the object. In effect, the entire structure pulsed in harmony with the rotating thermal wave. Further analysis by MIT's Deep Space Simulation Lab showed that the time delay between the thermal shift and its visible effects on the rings was roughly 2.3 seconds, the exact amount of time it would take for energy to move laterally across a body 200 meters wide at the conduction rate of advanced carbon composites. That number stunned analysts, because it meant one of 2 things. Either the object was made of unknown material with physics we can't model, or it was made of engineered material that someone else already has. Finally, as the looping heat continued throughout the morning, a new layer of complexity emerged. The loop occasionally paused. For 1 or 2 cycles, the hot zone would stop, stabilize in one position, and then resume moving, always picking up from the same place it left off. This memory-like behavior pointed to the presence of a feedback system, something monitoring and adjusting the motion from inside. Heat doesn't think, but systems do. In natural thermodynamics, energy dissipates. It never returns on cue. But in 3I Atlas it loops, cleanly, predictably, purposefully, and in that looping rhythm, something is being maintained, not lost. For the first time in modern astronomy, we're watching heat behave like logic. When NASA's Hubble Space Telescope locked onto 3I Atlas during its November 29th observation window, expectations were modest. Hubble had already provided critical imagery of the object weeks earlier, blurry but consistent with its assumed status as an unusually stable interstellar comet. But on this particular morning, something changed. What began as a routine high-contrast capture turned into a silent revelation, a shadow reading that defied every model in place. It started with a discrepancy in background light. As Hubble tracked 3I Atlas across a stable starfield, researchers noticed that several of the background stars directly behind the object dimmed, more than they should have. The expectation was standard. Comets scatter light diffusely, creating a translucent effect that may slightly lower stellar intensity in the background. But this drop wasn't diffuse. It was sudden, total, and angular. One star, HD 13422, dim to zero within milliseconds as 3i Atlas passed in front of it, a phenomenon known as stellar occultation. But unlike typical cometary occultations, the drop in brightness wasn't curved or gradual. It was a clean edge, a rectangular cutoff, followed by a sharp return. It resembled the shadow profile of a structured object with defined boundaries, not a dusty coma cloud. This behaviour repeated across 3 more stars, during that same pass, all of which exhibited the same pattern: a clean occlusion, a pause, and then a near instantaneous reappearance. The implication? 3i's Atlas wasn't just passing through, it was blocking light like a solid object. And not just that, the shape of the shadow changed, from rectangular to hexagonal to sharply peaked, depending on the angle of approach. It was as if different facets of a structured form were revealing themselves in silhouette as the object rotated ever so slightly. Hubble's optical instruments are among the most sensitive in existence, capable of detecting minor fluctuations in brightness at extreme distances. So the idea that 3i Atlas could cast such sharp-edged shadows raised immediate concern. In natural space bodies, especially icy comets, shadows are always softened by halos of dust and gas. But 3i Atlas had no such halo in this reading, just an abrupt drop in light, flat-lined brightness, and then a sudden restoration. More curious still, the shadows themselves were not aligned with the predicted orientation of the object's coma. According to the standard solar geometry, the tail of the object should have extended at least 40 degrees away from the solar vector, creating a trailing occlusion that would have lasted longer than the core. But that didn't happen. There was no extended tail signature in the shadow data, only a hard shadow consistent with a single, compact, possibly angular structure. The next anomaly came from the timing. Using the exact position of the dimmed stars and the motion speed of 3i Atlas, NASA's Goddard team calculated the approximate width of the structure casting the shadow. The result? Just over 213 meters. This matched earlier estimates of the core's physical dimensions, but what stood out was the uniformity. No irregularities, no jitter, no dust gradients, just a solid, structured pass. Even more telling was the way the light returned. When comets pass over stars, the fading and brightening usually takes several seconds, due to the diffuse nature of the coma and the random movement of particles. But in this case, the return to full starlight was instantaneous, as though an object had moved past with mechanical precision. No debris, no haze, no drift. ESA's independent review confirmed the results. Their background subtraction models, based on identical star fields, showed that 3i Atlas absorbed and released light without scatter, forming what one analyst called a photonic knife edge. Naturally, theories emerged. Could a dense material be reflecting the light instead of scattering it? Perhaps the object had collapsed its coma temporarily, but such behaviour has never been recorded, and the alignment across multiple stars ruled out coincidence. In a closed internal memo, one scientist wrote, "This is not a comet shadow, this is a cross-section." Whether that cross-section belongs to a rotating body, a layered hull, or a geometry we have yet to define, one truth emerged from Hubble's camera. We are no longer seeing a dusty interstellar wanderer. We are seeing something solid enough to cast a precise shadow in deep space, and in astronomy, shadows never lie. On November 29, 2025, as researchers tracked 3i Atlas using both ground-based and orbital observatories, a recurring pattern deep within the object's emissions began to emerge. This wasn't new. For weeks, 3i Atlas had been known for its peculiar 9.04-minute rhythmic pulses, faint but regular surges of brightness that baffled traditional models. But now a second rhythm had entered the frame. Nested within the main pulse, scientists detected a secondary flicker, faster, fainter, and perfectly synchronized. It was the unmistakable signature of a double pulse. The detection came from a collaborative effort between the Solar Dynamics Observatory, SDO, and ESA's Solar Orbiter, both of which had instruments tuned to high-speed photometry. During the latest cycle of observation, analysts noticed that just before each peak in the primary 9-minute pulse, a tiny subflash would occur, precisely 3 times in rapid succession. Each subpulse lasted less than 0.12 seconds and was spaced equally at gross 38-second intervals. The spacing was so exact, it prompted engineers to question their own equipment calibration. But when identical timing was confirmed by ground-based instruments in Chile and Hawaii, skepticism turned into a structured inquiry. This was not instrument noise. It was not cosmic interference. It was a coherent subpattern, one riding within the larger emissions wave, like a signal embedded in a carrier frequency. More remarkably, the ratio between the main pulse and the subpulses was exactly 3.1. That is, for every full brightness surge from 3i Atlas, there were 3 smaller, fainter flickers embedded in the lead-up. Physicists at Caltech described the phenomenon using terms more common to communications theory than astronomy. They likened it to amplitude modulation, where one wave contains the informational content of another. In other words, the object was not just emitting energy, it was encoding something into the rhythm. Each double pulse pair behaved like a binary marker, an energetic structure riding on the back of a broader emission cycle. Why does this matter? Because nature, while often rhythmic, is rarely precise across multiple domains. Comets can pulse from internal stress. Asteroids can tumble. Volcanic moons like Io exhibit periodic geysers due to tidal forces. But those rhythms are born of pressure and temperature, never digital timing. The triple subpulse inside 3i Atlas's core pulse never drifted, not by even a millisecond. That kind of consistency is mechanical, not geological. The implications only deepened when researchers compared spectral data. During each main pulse, the object brightened in the near-infrared, consistent with a temporary release of energy, but the subpulses exhibited a completely different profile, spiking in extreme ultraviolet. This divergence suggested the emissions weren't just smaller versions of the main event, they were coming from another source entirely, possibly located within a different layer of the object's core. One hypothesis suggested a 2-stage system. The primary pulse comes from external modulation, perhaps something like a rotating field, while the subpulses originate from internal capacitive discharge or reflective cycling. But again, this strays into language used in engineered systems, not celestial mechanics. Then came the structural model. By overlaying the pulse timing with the thermal delay maps recorded by JWST, analysts noted something shocking. The subpulses correlated spatially with the internal heat loop described in Chapter 3. Just as the rotating hot zone passed the midpoint of the core, a subpulse would trigger, as though energy was being discharged or redistributed in a controlled reaction. The consistency of the location added weight to the theory. These pulses weren't random bursts, they were responses. Amateur radio telescopes even reported weak electromagnetic echoes at each subpulse, further hinting that each event may involve electromagnetic realignment, not just light, but field restructuring. And finally, in one of the most curious alignments of the day, the double pulse signature matched a harmonic frequency seen weeks earlier in 3i Atlas's spectral modulations. The 3:1 ratio, the timing, the shape, all pointed to a systemic recurrence, the hallmark of a unified internal process. In a natural object, light doesn't organize itself into nested frequencies, but here we are watching a pulse within a pulse, a heartbeat within a rhythm, that holds time as if following a blueprint. Something inside 3i Atlas is counting, and the cosmos doesn't count without cause. While most interstellar objects are defined by motion, blazing tails, expanding comas, chaotic jets of sublimating ice, 3i Atlas shocked observers by displaying something profoundly unnatural: stillness. Not physical stillness in space, but thermal stillness, a heat distribution that refused to dissipate, drift, or decay. On the morning of November 29, 2025, this anomaly crystallized into what is now referred to by thermal analysts as the static thermal shell. The anomaly was first noticed by ESA's solar orbiter, which was running high-fidelity thermal scans at multiple wavelengths. Over a 2-hour observation window, the data showed an unusually smooth ring of elevated temperature surrounding the object, not unlike a halo, but one that didn't follow the expected behavior of dust or gas. In natural comets, sublimated gas spreads unevenly, responding chaotically to solar heating. The temperature field fluctuates constantly, stretched by particle velocity, disturbed by solar wind. But the heat field around 3i Atlas held firm. It formed a fixed shell, a thermal envelope, maintaining a uniform distance of approximately 19 kilometers from the core, and more disturbingly, it did not move. That meant no drift, no wobble, no cooling gradient trailing off in one direction. The thermal signature was wrapped like a casing around the object, as if it were being maintained by an invisible force or boundary layer. This puzzled scientists immediately. The sun was bombarding 3I Atlas with energy. The object was rotating, and yet this heat remained symmetrical and spatially consistent. NASA's infrared arrays on the James Webb Space Telescope confirmed the readings. But more importantly, JWST revealed the shell's internal structure. It wasn't just warm gas. It had banding, discrete radial temperature zones within the shell, each separated by roughly 2 kilometers. These were not random thermal fluctuations. They were clearly defined layers, with sharp transitions rather than smooth fades. One hypothesis proposed that we were seeing the aftermath of a transient event, a burst of sublimation that froze mid-expansion. But when analysts rewound older data, they found that the same thermal shell had existed for over 9 days with only minor variation. That kind of long-term thermal symmetry is unprecedented. In a moving sunlit object, heat doesn't just hold in a spherical shell. It flows outward, disperses, cools. This shell, however, did none of those things. A second, more radical explanation began circulating in private academic channels. What if the shell wasn't passive at all? What if it was controlled, maintained by an electromagnetic field or a form of internal modulation? If the object had the ability to regulate heat distribution around itself, it could in theory trap warmth in a spherical zone, preventing it from dispersing too quickly. In engineered systems, we call this thermal shielding. Spacecraft use it to protect their interiors from solar radiation or to mask heat signatures. But the idea of an interstellar object maintaining a perfect thermal cage around itself defies all natural categories. More evidence came when amateur telescopes using differential filters confirmed that the shell emitted more heat than the object's own surface during specific intervals. This suggested not just retention of solar energy, but possible re-emission, a heat balancing mechanism. The direction of maximum radiation also remained consistent with the object's forward vector, indicating that the shell was anchored to the body, not floating free as a cloud of particles would. Further analysis of energy distribution inside the shell revealed one more anomaly. Its interior was cooler than expected. Normally, if a heat shell forms around a warm object, the heat would build up inside, but 3I Atlas displayed a mild thermal inversion. The shell was warmer than the core at times, especially during its pulse cycles, which hinted at dynamic energy movement, an external mechanism drawing energy outward and suspending it just beyond the surface. This is not a phenomenon we observe in space debris, rocky asteroids, or icy comets. This is structure. Not a wall of gas, but a layered field. Not convection, but confinement. It's as if the object is wrapped in a thermal skin, calibrated, tuned, and possibly responding to its own internal cycles. Whatever 3I Atlas is, it's not just surviving the sun's energy, it's managing it. And the longer that shell holds, the more it looks like a decision, not a coincidence. One of the most quietly unsettling discoveries about 3I Atlas on the morning of November 29, 2025, came not from its emissions or heat signatures, but from its reflections. As observatories across the globe tracked the object's path, they began to notice something astronomically improbable. The light bouncing off 3I Atlas was not chaotic, variable, or diffuse like a comet's glow should be. Instead, it was repeating, in cycles, with measurable symmetry. The reflectivity of the object was patterned, and that pattern kept returning. This observation began with a routine set of polarized imaging passes from the ESA's VLT, Very Large Telescope in Chile, which was running a multi-angle brightness curve campaign. In normal comet observations, reflected sunlight scatters off irregular surfaces or off clouds of ejected particles. The result is noisy, unpredictable data with no consistent symmetry. But with 3I Atlas, the reflected light intensity peaked at identical angular positions during each observation pass. Even when taken hours apart under slightly shifted geometric alignments, with respect to the Sun and Earth, the intensity curve always followed the same 3 peaks, exactly 40 87 and 133. Each time the object rotated or changed aspect in its orbital position, the same reflectivity spikes returned. These angles, once plotted in 3 dimensions, formed a triad across the object's surface, almost like fixed mirrored panels embedded into its geometry. This behaviour shouldn't exist. Comets don't have panels. Their surfaces are rough, icy, and porous. Their albedo, the measure of reflectivity, is always inconsistent and directional. But 3I Atlas had an albedo curve that was machine-like. In fact, the only known objects that reflect light this consistently are artificial satellites and engineered reflective materials designed for thermal control or energy concentration. The idea that these were coincidence was eliminated quickly. Observatories in Hawaii, Spain, and South Africa all confirm the same angle-specific glints. More crucially, the timing of the peaks corresponded with the 9.04-minute pulse cycles already identified in its emissions. That is, the object didn't just reflect light consistently at specific angles, it did so on a synchronized timer. NASA's SOFIA Airborne Observatory, flying at high altitude above the Pacific, captured a full rotational brightness sweep and found a square wave pattern in the reflectivity data. The brightness didn't just increase and decrease gradually, it stepped up and down with linear transitions. That kind of reflectivity response isn't produced by ice or carbon. It's a known hallmark of composite materials with angle-dependent reflectance, such as those used in stealth technology or solar sail prototypes. Engineers at ESA were quietly stunned when they attempted to simulate the pattern. The only way to replicate the observed reflection peaks and intervals was to model an object with 3 flat angled facets, each with surface reflectivity over 80%, and a rotation rate that matched the known pulse rhythm. The computer-generated model produced glint patterns identical to the real data. The conclusion: if this object isn't artificial, it is the closest natural mimic of artificial geometry ever discovered. The story doesn't stop there. During the final phase of the observation window, adaptive optics systems at the Keck Observatory captured a brief high-resolution series of frames that showed something even more bizarre: a faint shadow line moving across the surface of 3I Atlas, perpendicular to the Sun's position. In other words, the object was not just reflecting light, it was shading part of itself. That implies elevation, edges, possibly structure casting structure. This observation supported a growing theory that the repeating reflectivity wasn't just a coincidence of surface features, it was a function of design. Objects that reflect sunlight in stable, repeating intervals are not chaotic. They are not fragments, they are not debris, they are assemblies. And on November 29th, the data made it impossible to deny that 3I Atlas was exhibiting directional light behavior tied to internal rhythm and external geometry, a reflective choreography that was consistent, measurable, and deliberate. Something out there isn't just catching light, it's reflecting with intention. In the early hours of November 29, 2025, telescopes across the globe recorded an event so fundamentally counterintuitive that many teams assumed it was an error in the initial data stream. At precisely 0412 UTC, 3I Atlas's core, previously confirmed to be rotating with a stable periodicity of roughly 9 minutes, stopped. Not gradually, not through deceleration. It halted almost instantly. But what followed next was even more perplexing. The object's emission pulses continued, unaffected. This event was first detected by the University of Tokyo's Flare Observatory, which had been monitoring photometric flux variations to track the object's rotation. The team had been relying on minor periodic dimmings, caused by presumed surface irregularities, to map rotational speed. That pattern had held consistently for weeks, a stable cycle of light fluctuation matching the 9.04-minute pulse window. But as the latest data came in, the light fluctuation vanished. The object's brightness became smooth and continuous. The rotational signature was simply gone. At first, the team assumed a mechanical issue with the photometer array. But simultaneous data from the European Southern Observatory, Pan-STARRS, and the Mauna Kea facilities all showed the same result. A sudden flattening of the brightness curve, beginning within a 2-second margin across all observatories. To confirm, NASA turned to the James Webb Space Telescope's infrared spectroscopy logs. Those logs had been recording minor Doppler shifts in emissions from one side of the object to the other, a direct indicator of motion. But starting at 0412 UTC, those Doppler signatures vanished. The rotational differential was no longer present. The object, at least in observable terms, had ceased rotating. Yet the pulses remained, and they remained perfectly on schedule. Every 9:04 minutes the same ultraviolet surge appeared, the same nested sub-pulses, the same heat fluctuations in the surrounding shell. No delay, no drift, no loss in signal strength. The heartbeat of 3i Atlas continued without interruption, even though its body had stopped moving. This disconnection between rotation and pulse behaviour shattered what little remained of the natural object hypothesis. In comets, rotation is the engine. It drives sublimation, tail dynamics, even brightness variation. But 3i Atlas had now demonstrated that its internal energy output was decoupled from its physical orientation in space. This behaviour has no precedent in astrophysics. To stop a spinning object that's hundreds of meters wide and travelling at tens of kilometers per second would require a colossal input of force, something that should produce visible shock waves, fragment ejection, or catastrophic instability. But 3i Atlas remained perfectly intact. There was no mass shedding, no structural deformation, no increase in dust output. It was as if the object had simply chosen to pause. Engineers at MIT's Space Dynamics Laboratory ran simulations to test whether known natural events, like torque from asymmetrical outgassing or abrupt surface collapse, could account for the rotational halt. Every model failed. The object's thermal symmetry remained untouched. Its trajectory remained stable. Even its interaction with solar radiation showed no sudden shift. There was no known cause. Then came the strangest detail of all. The emission pulses became slightly cleaner after the rotation stopped. Their frequency was unchanged, but their waveform smoothed. The noise envelope shrank. The emissions became purer, as though freed from interference. That level of control implies one thing: internal regulation. It's as if the object halted its own spin to stabilize an ongoing operation, like a satellite stopping its rotation to lock onto a target or fire a precision burst. If that sounds engineered, that's because it is. One internal memo from ESA described it this way: "We are no longer observing a natural rotation curve. We are witnessing active orientation management." And here lies the paradox. Comets do not pause to steady their emissions. Asteroids do not switch off their momentum to improve signal clarity. Only systems with internal logic do that. Only systems with purpose. So the question shifts, not what caused the rotation to stop, but why did it stop and what began immediately after? Because in that silence of spin, something inside 3i Atlas became louder, more deliberate, and perhaps, for the first time, fully awake. When the James Webb Space Telescope ran a series of long-exposure infrared scans on 3i Atlas during the early hours of November 29th, analysts expected a turbulent, uneven heat signature, typical of celestial objects passing through highly irradiated regions near the inner solar system. Instead, what they uncovered was something so improbable it sparked a wave of internal reviews, private alerts, and encrypted exchanges between NASA, ESA, and the Japanese Aerospace Exploration Agency. The anomaly was this: a single cold region, circular, sharply defined, and geometrically perfect, located on the object's equatorial band. It was not a faded area of emission or a cooling pocket, but an absolute absence of detectable infrared radiation. A perfectly circular cold spot measuring precisely 42 meters in diameter, with a margin of deviation of less than 0.3%. This isn't something that forms in nature. On rotating bodies like comets, especially those undergoing thermal stress near a star, surface temperatures vary due to uneven solar exposure, outgassing events, or chemical composition. But what the Webb data showed was neither a rough patch nor a compositional anomaly. This spot was deliberately shaped, as though carved into the object, or more disturbingly, as if it were an engineered surface feature. The temperature differential itself was just as shocking. The cold spot measured 32 Kelvin colder than the surrounding surface. That means it was not just shaded, it was actively emitting less infrared radiation than any other part of the structure, including areas fully turned away from the sun. At first, this seemed like an imaging artifact, but after ESA's mid-infrared survey confirmed the result, and JAXA's Akari telescope produced identical values, the data became undeniable. Multiple instruments across independent agencies were seeing the same thing: a circular low-radiation zone on an object that is otherwise layered in thermal dynamics. But the real question was, Why was it so perfect? Infrared mapping tools at NASA's Goddard Institute ran a series of 3D reconstructions using the thermal data, attempting to identify whether the cold spot was a concavity, a depression, or a material contrast. But the results showed something different: flatness. The cold region wasn't a hole or a crater. It had zero measurable curvature. Its plane was even. Not only that, but it also sat flush with the object's surface. No drop-off, no slope, no indentation. Even more unsettling was its behavior. As 3i Atlas rotated, before the full rotational halt described in Chapter 8, the cold spot maintained its alignment toward deep space. It did not rotate in sync with the object. Instead, it tracked a fixed stellar vector, almost like a port or hatch aligning with a celestial reference point. This observation ignited intense speculation among mission scientists. Some suspected a passive thermal management panel, like those used on classified Earth-orbiting satellites. Others hypothesized it might be a field generator, a region designed to suppress infrared emissions intentionally, masking heat from detection. But why would any object, natural or artificial, need to hide its temperature from observation? One possibility emerged from comparative orbital dynamics. The cold spot's alignment mirrored the incoming angle of the Swan object, another anomaly approaching the solar system discussed in earlier reports. This suggested that the cold zone may not be about hiding from Earth, but about communicating directionally or syncing with another object entirely. The silence of the spot became its own form of message. No natural body forms a 42-meter-wide zone of cold that remains planar, precisely shaped, and locked onto a stellar coordinate. That kind of suppression isn't just unlikely, it's impossible without deliberate design. And if that spot was manufactured, intended to shield, aim, or emit in another form we haven't yet detected, then 3i Atlas has crossed a threshold. It is no longer an object of observation, it is an object making choices. In space, silence can mean many things. But when silence is shaped, stabilized, and maintained across light years, it begins to look less like absence and more like intention. At exactly 0658 UTC on November 29, 2025, a lesser-known solar monitoring station in La Palma, Spain, equipped with high-sensitivity magnetometer arrays, recorded something it couldn't immediately explain: a soft, curling disturbance in the local electromagnetic field, faint but persistent, synchronized with the trajectory of 3i Atlas. What began as a minor anomaly in the magnetosphere logs quickly escalated into one of the most whispered-about findings of the entire 3i Atlas investigation: frame drag behavior in the object's electromagnetic wake. To the uninitiated, frame drag is a concept rooted in general relativity. It's the idea that a massive rotating object can distort the very fabric of space-time around it, pulling nearby matter and fields along with it. We observe something similar near black holes and neutron stars, where immense mass and rotation twist gravity and light into spirals. But here's the problem: 3i Atlas isn't massive enough to do that. It's no black hole, no collapsed star, and yet something in its wake was dragging. ESA's magnetic anomaly team confirmed it the same afternoon. As 3i Atlas moved through space, it left behind not just ionized particles or dust, but a twisting polarization effect, a subtle curling of the ambient magnetic field in a toroidal pattern, recorded in 5-second intervals. The effect was faint but measurable. Satellites in Earth's upper ionosphere picked it up as well. The wake wasn't static. It spiraled behind the object in a tight helical coil, like the contrail of a jet, but made of field lines, not vapor. Even stranger, this distortion extended far beyond the object's mass envelope. The measured radius of the wake was over 12 kilometers wide, despite 3i Atlas being only a few hundred meters across. That kind of field drag can't be explained by any passive motion. It implies that the object is interacting actively with the local magnetic field, perhaps by emitting an oscillating electromagnetic signal of its own. NASA's Goddard lab took a closer look by overlaying the wake geometry with previously known solar wind flow patterns. The result: the wake didn't follow the solar wind, it overrode it. It reshaped local flow vectors for over 0.7 seconds before the solar wind reasserted dominance. This confirmed a critical hypothesis. The object isn't just drifting through space, it's generating a transient zone of electromagnetic influence. physicists scrambled to categorize this. One theory suggested that if 3I Atlas had an internal plasma field rotating at high speeds, it might produce a temporary Lorentz distortion effect, a localized warping of magnetic field lines similar to a tokamak fusion reactor on Earth. But again, the precision was off the charts. The curl ratio of the frame drag, its helical symmetry, remained exactly 1.618 to 1, the golden ratio across all measured samples. In other words, the wake wasn't random, it was structured. There are no known natural processes that generate golden ratio helical magnetic trails in interplanetary space. That level of order is the hallmark of resonant engineering, designs where form meets function, where energy distribution is managed deliberately to reduce chaos. Then came the most jarring discovery. Hidden within the spiral wake were polarization flips, precise 180-degree field inversions occurring every 27 seconds. These flips happened like clockwork, regardless of solar wind strength, object distance, or thermal fluctuation. That's not interference. That's timed modulation. And it's eerily similar to frequency hopping in military communication arrays, where signal stealth and resilience are essential. So what does it mean? The magnetic trail of 3I Atlas is not just a footprint, it's a signature, a rhythmic, spiraling, timed electromagnetic pattern that does not match cometary ion tails or asteroid plumes. It echoes something else entirely: propulsion physics, field stabilization, or even message encoding. In this frame-dragging electromagnetic wake, nature seems to step back and intention steps forward. Because when a cold, silent object begins leaving behind spiraled fingerprints that twist the magnetic fabric of space, the question is no longer what it is, but who calibrated it. One of the most overlooked, yet profoundly unsettling moments in the 3I Atlas timeline occurred at 0716 UTC on the morning of November 29, 2025. It wasn't marked by a flash or a signal spike. There was no heat surge, no violent expulsion of gas or debris. Instead, what unfolded was far more eerie. Everything went quiet. For just under 4 minutes, all signs of solar interaction with 3I Atlas, thermal, electromagnetic, and ionized, flatlined. The object didn't just ignore the sun, it disengaged from it entirely. This anomaly first came to light when NOAA's Dieskova satellite registered a complete absence of reflected solar radiation from the object. Previously, 3I Atlas had been producing a measurable reflection curve that changed subtly with its position and distance to the sun. But suddenly, that curve collapsed to zero, not because the object moved out of view, but because it appeared to stop interacting with sunlight at all. Simultaneously, NASA's Solar Dynamics Observatory flagged a drop in photoionization values near the object's coordinates. These values normally spike around objects approaching the inner solar system, where ultraviolet radiation strips electrons from their outer shells, creating bright plumes of energized gas. But for those 4 minutes, 3I Atlas stopped glowing. No ionized gases, no halo, just darkness. More remarkably, the solar wind, which had been interacting with the object's outer boundary, suddenly passed through it, as if it weren't there. Data from the Parker Solar Probe showed no deflection in particle flow across the region 3I Atlas occupied. It was as though the object had briefly ceased to exist within the solar plasma environment. This wasn't a telescope glitch. Multiple instruments, including ESA's Solar Orbiter and JAXA's Hinode Observatory, picked up the same null reading across different bands: visible, ultraviolet, X-ray, and solar wind flux. There was no ejection event, no orientation change, and no interference. The sun was behaving normally. It was only 3I Atlas that had turned off, or more precisely, turned invisible to solar forces. But how? This event sparked a frantic investigation into the object's composition. Some proposed that it had deployed a form of adaptive radiation shielding, a field or surface condition that perfectly counteracted incoming energy. Others speculated it might have engaged electromagnetic cloaking to redirect incoming radiation, a concept still theoretical in human engineering but conceivable in controlled plasma physics. The most conservative voices suggested a shift in surface composition, perhaps the exposure of a non-reflective layer. But that didn't account for the complete loss of ionization and solar wind deflection. The object had not just stopped glowing, it had stopped interacting. Even more haunting was what followed immediately after the pause: At exactly 0720 UTC, the object returned to its previous state, but with increased emissions across every band. The reflective index jumped by 11%. The ionization field surged to 140% of its pre-pause baseline, and the electromagnetic field strength at the perimeter of the object doubled within 30 seconds. It was as if 3i Atlas had reset, or more disturbingly, charged itself during the silence. Scientists familiar with stealth systems noted the similarity to pulse cloaking, a technique where an object absorbs incoming energy, stores it, then re-releases it in a more focused form. But for this to happen on a celestial scale, without mass loss or structural change, suggests the presence of active field manipulation beyond anything in natural astrophysics. So what was the purpose of this pause? One theory is that it represented a calibration event, a moment when the object insulated itself from all external forces to run internal diagnostics or reorient its internal systems. Another theory is far more unsettling, that 3i Atlas was briefly aligning itself with something else, perhaps another object, field or signal, and required complete environmental silence to do so. Whatever the reason, that pause left a fingerprint unlike anything we've seen. Because in space, objects don't just stop interacting with the sun, not without technology, not without control. And in those 4 minutes of silence, we may have glimpsed the one thing no telescope can fully measure: agency. At 0844 UTC on the morning of November 29th, 2025, an unexpected pattern emerged from the spectral photometry data being collected across 5 observatories, 2 in the northern hemisphere and 3 in the southern. It wasn't a thermal anomaly or a shift in mass trajectory. This time, it was something even harder to explain. 3 distinct orthogonal axes of reflected light emerging from 3i Atlas. That's not metaphor. It was literal. Unlike comets or asteroids, which scatter sunlight in chaotic, diffuse halos due to their irregular spinning surfaces and outgassing plumes, 3i Atlas began reflecting incoming sunlight along 3 sharply defined planes. These reflections weren't dependent on the observer's angle. In fact, the pattern remained consistent across radically different positions, suggesting that the object's reflectivity was governed not by geometry, but by internal coordination. Let's break down the discovery. The first detection came from Chile's Cerro Paranal Observatory, which noticed an anomalous spike in reflected solar radiation at an angle of 48 Jun east of solar incidence. Nothing in the object's structure should have produced a sharp reflectivity curve from that direction, unless it had a flat or polished surface capable of directing light precisely. 10 minutes later, the Mount Graham International Observatory in Arizona observed the exact same spike, not from 48 Digrin but from a perpendicular axis, 96 Dig, while another station in Western Australia logged a reflection at a full vertical axis, nearly 90 degrees above the solar plane. Combined, these 3 observations formed a triaxial grid, X, Y, and Z, centered on the object. In short, 3i Atlas was reflecting light in a controlled way along all 3 spatial dimensions. This is unprecedented. Celestial bodies don't reflect like that. Even artificial satellites rarely do. Our best engineered probes reflect sunlight only when panels or hulls catch the angle, and never across 3 spatial axes simultaneously. But here, 3i Atlas demonstrated what analysts called persistent geometric reflection, a trivector signature of controlled material response. The implications were immediate and disorienting. Engineers at the ESA speculated that this could indicate a modular outer shell, perhaps composed of independently aligned surfaces that are capable of rotating or shifting their optical properties. Others proposed a crystalline lattice structure, something akin to metamaterials on Earth that can manipulate reflectivity and absorption at the nanoscale. But the simplest explanation, the one nobody wanted to speak aloud, was this: it's designed. These reflections didn't vary with object rotation. They weren't tied to position or attitude. Even as 3i Atlas continued through its deceleration phase, the 3 axes of reflection remained consistent, almost like navigation beacons or alignment markers, broadcasting orientation not to Earth, but possibly to something beyond it. Even stranger, the reflected light was not spectrally uniform. It wasn't just bouncing white sunlight, it was spectrally shifted at each axis. The x-axis beam showed a slight blue bias, indicating tighter wave compression, while the y-axis returned a neutral spectral signature, and the z-axis reflected in the near-infrared band with a faint thermal modulation pattern superimposed. Scientists attempted to replicate the pattern in lab simulations using spherical composite models. Every simulation failed unless the object was modelled with active light phase modulation, a system by which incoming photons are redirected through layered dielectric structures. In Earth-based technology, such a feat is only achievable in controlled optics labs or defense-grade phased array systems. And yet here was a supposed comet doing it in interplanetary space. Some researchers, whispering in secured Slack channels and off-record briefings, began calling the light reflections the tribeacons. The implication? That 3i Atlas isn't simply reflecting for passive reasons, but broadcasting alignment. Like a probe locking its orientation in space using light as a language. The tri-axis reflection has remained stable ever since its appearance. No decay, no rotational variance, just perfect alignment, 600,000 kilometers from Earth, in a silent glide through solar proximity. Light, in this case, isn't merely illuminating an object. It's telling us where it's looking, and possibly who it's waiting for. At precisely 09:03 UTC on the morning of November 29, 2025, observatories across 4 continents picked up a familiar pattern that hadn't been seen in over 6 days, a low-frequency sub-pulse flicker emanating from 3i Atlas's core, one that had been observed in its early phase but had mysteriously gone silent during the object's acceleration near solar perihelion. The return of this flicker didn't just reignite interest, it reframed everything. The initial appearance of the sub-pulse pattern had been noted in late October as a series of tightly packed oscillations embedded within the larger ultraviolet pulse emissions from the core. These sub-pulses, spaced roughly 0.42 seconds apart, had been dismissed at first as an instrument calibration issue. But after cross-verification with independent telescopes in Hawaii, South Africa and Japan, it became clear. This was a real, rhythmic signal, layered beneath the broader emission field. But then, after November 23rd, it stopped. The sudden absence of the sub-pulse flicker was one of the many subtle signs that 3i Atlas was undergoing internal change. Some hypothesized it had exhausted a volatile material. Others suspected the pulses were a byproduct of angular momentum, or possibly structural oscillation as it tumbled through space. Either way, it was gone, until now. The return came without warning but with perfect rhythm. The same 0.42 second spacing, the same tight modulation curve. But this time, it carried something new, a modulated harmonic that wasn't present in the original signal. This harmonic, detected by the European Space Agency's Fourier Analysis Division, suggested that the object's internal activity had not only resumed, it had evolved. Imagine hearing a heartbeat, and then one day the same heartbeat returns with a second pulse riding inside it. That's what analysts saw in the sub-pulse flicker, not just a signal, but a signal carrying information. More than 25 instruments confirmed the reappearance, from radio telescopes in the Atacama Desert to deep space receivers on board the Lunar Gateway. But what stunned engineers wasn't just the timing, it was the uniformity. No matter where you looked from, Earth, lunar orbit or low Mars relay stations, the timing was identical to the microsecond. That level of signal coherence across astronomical distances and observational positions is impossible without coordination. It was behaving like a synchronized emitter. But what is it emitting? Some hypothesized that the sub-pulse flicker could be thermal regulation, internal heat cycling due to compositional change. But thermal cycling doesn't produce clockwork electromagnetic flickers. Others proposed electrical discharge from subsurface crystalline fractures, but again, random fracturing doesn't repeat at 0.42 second intervals for hours on end. Instead, the leading theory now points toward deliberate internal signaling, possibly an autonomous loop triggered after a system reset. This theory gained traction when 3 separate AI-aided data models, run independently by teams at JPL, CNRS and DLR, found the flicker's harmonics aligned with nested recursive sequences, something found in coded systems rather than random emissions. Simply put, this isn't noise, it's structured output. And there's one more disturbing detail. The reactivated flicker replaced one of the previous broader pulses. Where the core used to emit an ultraviolet surge every 904 minutes, it now emitted a compressed hybrid pulse that included the old signal's shape plus the embedded subpulses. That transition suggests that the internal system made a deliberate substitution, as if upgrading its language, switching from a beacon to something more complex. Several analysts called the pattern verbal, not in the linguistic sense, but in the way it builds upon itself, layering repetitions with slight shifts, creating the waveform equivalent of phrases. Whether or not that interpretation holds up, one thing is clear: 3i Atlas is not just emitting energy, it is now repeating, refining, and embedding structure inside those emissions. The return of the subpulse flicker is not just a signal reactivation, it's a return to speech. And someone, or something, is still on the other end listening. Just minutes after the reactivation of the subpulse flicker described in the previous chapter, another anomaly, deeper, stranger, and even harder to explain, emerged from the data. At 09:11 UTC on the morning of November 29, 2025, the European Infrasound Array, EA, in Finland, originally designed to detect deep Earth seismic tremors and atmospheric detonations, registered something completely unexpected: a harmonic echo, not from underground, but from deep space. The source? None other than 3i Atlas. This anomaly didn't appear in the visible spectrum or even the usual EM bands. It was found in a much lower energy band, something closer to infrasound wave resonance, yet somehow travelling through the vacuum of space, where sound, as we know it, can't even exist. The echo arrived as a series of repeating, gradually decaying wavefronts, almost like a bell being struck in an airless cathedral. But instead of travelling through a medium, these echoes were refracted light-based signatures, bending and scattering as they pulsed outward from the object. Multiple Earth-based and orbital sensors recorded the same pattern at staggered intervals, timed precisely to the rotational phase lock of 3i Atlas. At first, analysts were baffled. The data didn't match any known cometary emissions, magnetic field disruptions, or light flares. What stood out was the mathematical harmony between the pulses. Each echo contained nested harmonic intervals, fractions of the golden ratio, Fibonacci recursions, and prime number symmetry. In plain terms, this wasn't just a reflection. This was designed resonance. When split into waveforms, each echo behaved like a refraction artifact, similar to the way glass bends light, but on a vastly larger and more complex scale. Instruments on the James Webb Space Telescope revealed that the echoes originated not from the comet's core, but from a structured field perimeter roughly 600 meters in diameter. That perimeter appeared to phase in and out of visibility, depending on the angle of solar illumination, suggesting it might be a shell of energy, or more radically, a non-material lattice bending incoming light into resonant harmonics. And it gets stranger. Each harmonic echo decayed over a consistent time signature, 88.6 seconds to be exact. But this was no random drop-off. The decay curve followed a logarithmic spiral, identical to the sound dissipation profiles of Tibetan singing bowls or precision-manufactured steel rings. In human-engineered systems, this kind of decay control is only possible when the vibrating structure is tuned to exact physical tolerances. In space, with no medium and no pressure, it should be impossible. Yet 3i Atlas did it. And it didn't just do it once. It repeated the harmonic echo every 11.4 minutes, on a clockwork schedule, producing not just resonance, but predictable, directed resonance. This repetition, paired with the angular dependent refraction, led researchers to suspect that the object might be modulating space itself, creating transient lenses that shift the path of photons in a way that mirrors high-energy lensing experiments done at particle accelerators on Earth. One working theory, still considered fringe even among the more adventurous physicists, is that 3i Atlas is equipped with a phased resonance array, capable of emitting pulses that interact with the quantum vacuum. If true, this would mean the object isn't reflecting solar energy. It's converting it into structured waveforms that carry encoded data or shape the surrounding space. The final confirmation came when the echoes were mapped across 4 dimensions: time, space, amplitude, and frequency slope. What emerged was not a noise signature, but a fractal geometry, complete with recursive nodal points and harmonic junctions. These echoes weren't just phenomena, they were templates. Templates of what? No one knows yet. But some have suggested they might be alignment scaffolds, used to sync 3i Atlas with an external structure, or even prepare it for docking with something we haven't seen yet. What we do know is this. Light does not normally echo, photons do not bend into harmonic spirals, and space does not sing, unless someone taught it how. And somewhere out there, in the silence of interstellar vacuum, something is still ringing. At 09:27 UTC on the morning of November 29, 2025, a quiet alert was issued from NASA's Solar Ultraviolet Measurement of Emitted Radiation (SUMA) team. What began as a routine observation of ultraviolet scatter fields near 3I Atlas turned into one of the most visually compelling and scientifically unnerving discoveries of the entire mission. The data showed that the object was producing a structured UV emission pattern that distinctly formed the shape of an X, projected outward across a radius of nearly 2,000 kilometers. This wasn't a symbolic interpretation or a coincidence in shape. It was a precise, symmetrical double-beam projection, visible only in the far ultraviolet spectrum and measurable across multiple frames. And most concerning of all, the X wasn't reflecting light, it was generating it. Ultraviolet emissions from natural comets typically arise from the photodissociation of water molecules driven by solar radiation. The resulting Lyman alpha glow appears as a soft, irregular haze, chaotic and constantly changing, depending on how much gas is being released. But what Summer captured from 3I Atlas didn't behave that way. The emission wasn't diffuse, nor was it fluctuating based on solar proximity. It was anchored. Two intersecting beams originating from fixed points on the object's structure, crossing at a perfectly centered axis near the geometric core. Further verification came within minutes. ESA's solar orbiter confirmed the X pattern from a completely different vantage point, while the Japanese Hisaki satellite, designed to observe planetary exospheres, recorded a steady ultraviolet intensity that pulsed every 4.1 minutes, synchronized with the known sub-pulse emissions previously detected in lower frequencies. When overlaid, the UV X pulses and the internal sub-pulse flicker matched frame for frame. This alone was extraordinary. But what followed next pushed the phenomenon into unknown territory. As Earth rotated, observatories in South Africa and India picked up something shocking. The X rotated. Not with the spin of the comet itself, which had nearly ceased days earlier, but in an independent orientation, maintaining its axis relative to the Sun, not to the object's mass. This suggested a behavior almost like solar tracking or targeted emission stabilization, where the beams were correcting their position in real time. What kind of natural object adjusts UV output to maintain solar alignment? Spectrography added another layer of intrigue. The emissions were not broadband ultraviolet, but tightly tuned around UVC wavelengths, specifically 254 nanometers, a frequency commonly used in Earth-based laboratories for molecular sterilization and precision signaling. These aren't bands that appear randomly in space. They are too specific, too focused, and too engineered. Theories began to surface. One proposed that the X represented a navigation array used to maintain triangulated position during interstellar travel. Another saw it as a transmission beacon, possibly signaling location or orientation to an external receiver. But the most radical interpretation, and the one gaining quiet, traction among private defense contractors monitoring the data feed, is that the UVX is a targeting structure. Not in the weaponized sense, but as part of a deployment matrix, used to identify or stabilize a specific plane in three-dimensional space, maybe for insertion or anchoring into a larger framework. Researchers compared the phenomenon to phase array radar, where multiple beam emissions are used to sculpt invisible geometric fields. In military terms, this is how you lock position without relying on GPS. In space terms, it could be how you lock phase with another structure, or an entry point. And then came the final anomaly. When researchers plotted the X over time, its arms aligned, for just under 40 seconds, with the Earth-Sun vector, forming a direct orientation between the object's core and our planet. During this alignment, a subtle increase in reflected microwave emissions was recorded, suggesting that the object was not just pointing toward us, it was activating something. Whether this was coincidence, calibration, or intentional signal targeting remains unknown. But from that moment forward, the X has remained persistent, steady, ultraviolet, and watching. In a universe of randomness and dust, this kind of structured emission doesn't just stand out, it declares intent. At 09:41 UTC on the morning of November 29, 2025, while observatories were still reviewing ultraviolet anomalies from the rotating X emission described in the previous chapter, another critical and far more physical event unfolded. For nearly 12 full minutes, 3I Atlas, once considered a highly active comet with sporadic plasma bursts, went completely dark in the solar plasma bands. Then, without warning, it reactivated, but this time it wasn't chaotic. The plasma returned in a grid, and that changed everything. Historically, 3I Atlas had exhibited intermittent bursts of ionized gas, forming faint plumes along its presumed rotational path. These emissions aligned with what scientists expected from volatile materials reacting to solar radiation: messy, uneven, explosive. But at precisely 9:41 UTC, the object's entire plasma signature vanished. No flares, no trails, no magnetic eddies. Instruments that had been picking up highly ionized particles suddenly went flat. The silence was total, and it wasn't instrumental error. The Deep Space Magnetospheric Array, DSMA, the Solar Dynamics Observatory, SDO, and even the Parker Solar Probe confirmed the data. Plasma emissions dropped to zero. The region around 3I Atlas became electromagnetically still, despite the object's proximity to intense solar wind streams that should have continued exciting its surface. But what followed defied all known models. At 09:53 UTC, the plasma re-emerged, not as a flare or bloom, but as discrete linear strands. These threads of ionized material extended outward from the object's core, not randomly, but along clean geometric lines, creating what observers quickly began calling a plasma grid. It consisted of 9 perfectly spaced horizontal striations intersected by 6 vertical emissions, forming a 3-dimensional lattice that rotated independently of solar wind vectors. This was not how plasma behaves. Under natural conditions, plasma reacts to gravitational forces, solar radiation, and the magnetic field of the object itself. But in this case, the emission lines defied both the object's motion and its orientation. They were fixed, orthogonal, and pulsing at steady intervals, suggesting internal regulation. In short, the grid wasn't responding to the environment. It was operating on its own schedule. Spectral analysis of the strands showed varying ionization densities. The vertical lines emitted higher energy particles, dominated by helium and carbon ions, while the horizontal lines produced cooler emissions, rich in oxygen and trace metals like magnesium. This kind of selective ionization implies that the plasma isn't being randomly ejected, but filtered or channeled through layers of the object's structure. But the biggest shock came when researchers overlaid the plasma grid with previous data from the ultraviolet X emissions. They matched. The arms of the ultraviolet X aligned precisely with the corners of the plasma grid, suggesting that the emissions were not only coordinated, but connected. In other words, the object wasn't just emitting energy in different bands, it was creating a unified spatial framework, using plasma and ultraviolet light as structural scaffolding. One of the more controversial interpretations presented by the EA's plasma dynamics team was that 3I Atlas was exhibiting signs of field manipulation, essentially using plasma as architecture, not as exhaust. This would mean the object isn't reacting to space, but building within it. Some scientists cautiously compared the grid pattern to magnetic containment fields used in experimental fusion reactors like ITER, where electromagnetic lattices are used to confine plasma for extended periods. Others reference solar sails or phased laser arrays, systems that rely on highly structured emission fields to stabilize or propel spacecraft. But none of those systems exist inside a comet. As the grid stabilized, its edges began to oscillate subtly, creating interference fringes that resembled diffraction patterns, a clear sign of intentional wave manipulation. These patterns are usually only seen when multiple coherent sources interfere, like lasers in a lab. Except now it was happening 600,000 kilometers from Earth, around an object we once labeled a rock. The reappearance of plasma in a perfect grid wasn't just an optical oddity, it marked the moment when 3I Atlas stopped behaving like a comet and started behaving like a machine, and it left one question echoing across mission control boards around the world. If this is a machine, what is it building? At 10:06 UTC, on the morning of November 29, 2025, the James Webb Space Telescope locked onto a deep infrared anomaly inside the core of 3I Atlas, one that would defy decades of expectations about the internal composition of interstellar objects. For the first time since its arrival in our solar system, Webb's mid-infrared instrument, MIRI, had a clear, uninterrupted line of sight into the body's inner structure. What it captured was not just thermal fluctuation or internal brightness, it was a full-scale phase shift inside the object's material core. The term phase shift typically refers to changes in physical state, solid to liquid, gas to plasma, or some hybrid in between. But what Webb observed didn't match any of these familiar transitions. Instead, it recorded a spatial realignment of matter itself, as though the internal configuration of particles inside 3I Atlas had changed without changing state, like something subtly reshuffling at the quantum level. This shift wasn't chaotic or sudden. It was measured, rhythmic, and precisely timed to the moment the plasma grid stabilized around the object's exterior, a moment already considered groundbreaking. As the outer shell arranged itself into a lattice of luminous pulsing plasma, the inside of the object responded in kind, but in a much stranger way. Infrared tomography revealed that the core's central thermal signature split into two distinct lobes, each rotating in opposite directions. This kind of bifurcation doesn't exist in naturally formed rock bodies. It's more common in mechanical gyroscopes or stabilized inertial systems, where mass is separated and spun to generate artificial balance or control. But that was just the beginning. Webb's spectrometric analysis then showed something truly bizarre. The material between the two lobes began to refract light asymmetrically, not evenly like transparent ice, but more like programmable metamaterials. These synthetic materials, used on Earth for cloaking devices and radar absorption, are designed to redirect electromagnetic waves with mathematical precision, and now 3I Atlas appeared to be doing just that, from the inside out. The implication was staggering. The object's core was not fixed. It was active, responsive to its environment, and capable of reorganizing itself structurally and optically. By 1010 UTC, Webb's instruments detected phase flicker, a pattern of microscopic distortions in photon travel time across the inner core region. Normally, light travels at a constant speed through a given medium, but in this case, the travel time varied every 0.03 seconds in a cyclical pattern, suggesting that the internal refractive index of the object was oscillating, almost like a heartbeat. Even more shockingly, those internal phase oscillations were found to be in perfect resonance with the subpulse flicker and UV-X emission previously described. Three distinct phenomena, plasma structuring, ultraviolet targeting, and now internal core modulation, were all operating on the same timing rhythm. No known natural object maintains synchronized emissions across multiple energetic layers. This level of orchestration typically only exists in network systems. And then came the alignment test. Scientists mapped the directionality of the refracted emissions and found that at regular intervals, the internal phase shift created tunneling corridors, zones of reduced energy density that radiated outward like spokes in a wheel. These corridors were too structured to be natural and too symmetrical to be accidental. They aligned with certain regions of space, specifically toward Earth, Mars, and Lagrange point 4. In short, the internal changes appeared to be part of a broader targeting or mapping system. Theories erupted immediately. Was this a communication system, a form of propulsion calibration, a quantum positioning array? Or was this a data structuring core gathering and processing field information from multiple points in the solar system? No one knows for sure. But what is known, confirmed by Webb and peer-reviewed in near real time, is that something inside 3I Atlas is awake, and it's no longer just a traveller. It's actively reconfiguring its internal space, as though preparing for a second phase, or a purpose we're not meant to understand. At 10:23 UTC on the morning of November 29, 2025, scientists at the Mauna Loa Atmospheric Observatory in Hawaii reported a subtle but undeniable shift in the upper layers of Earth's ionosphere. The readings initially appeared to be anomalous, minor fluctuations in ion density, unaligned with known solar weather or geomagnetic storms. But within the hour, observatories across the globe began reporting the same thing, a patterned resonance in the atmosphere. This was the beginning of what would later be called the echo effect, a global phenomenon tied directly to 3I Atlas, and unlike anything previously recorded. At first, the changes were faint, variations in VLF, very low frequency, radio wave propagation, typically used to study lightning events and auroral behavior. But then, the anomalies became coherent, meaning the signals aligned in consistent intervals and spread across wide geographical regions. From Tromsø in Norway to Tierra del Fuego in Argentina, instruments recorded the same rhythmic fluctuations at exactly the same time. The question wasn't whether this was real. The question was, what was causing it? Simultaneously, space weather satellites in orbit detected no significant coronal mass ejections or magnetic reconnection events that could account for the shift. Solar activity was normal. There were no nearby gamma bursts or anomalous radiation spikes. Yet Earth's upper atmosphere behaved as if it were receiving a patterned signal, and that signal was coming from 3I Atlas. The timing was precise. The onset of the atmospheric echo effect occurred exactly 12 minutes after James Webb detected the internal phase shift in 3I Atlas's core. This led researchers to speculate, was the object not only reconfiguring its interior, but also broadcasting a form of low-energy signal across interplanetary distances? To understand the mechanics, we must first look at how Earth's ionosphere works. It acts like a giant mirror for certain radio frequencies, especially VLF and ELF, extremely low-frequency waves. Any directed emission capable of modulating these frequencies would effectively be able to ripple through the upper atmosphere, much like sonar in the ocean, and that's exactly what appeared to be happening. The echoes followed a pattern, 5 short bursts spaced evenly across a 37-second interval, then a 90-second pause, then the cycle would repeat. These were not artifacts of human technology or random space weather. The echoes propagated globally, travelling from pole to pole with astonishing uniformity. Even classified military sensors, designed to detect nuclear detonations and stealth communications, picked up the signature and flagged it as non-terrestrial and non-random. Further analysis revealed that each burst carried an embedded frequency modulation. This modulation wasn't just signal variation, it encoded a fractal structure, similar to what had been observed in the harmonic echoes from 3I Atlas days earlier. The structure was consistent with recursive geometry, self-similar patterns repeating at different scales. On Earth, such patterns are used in encrypted quantum signaling and optical data compression. But how could a comet, even an interstellar one, generate such structured influence on Earth's upper atmosphere? One hypothesis is that the internal phase shift within 3I Atlas activated a form of low-frequency gravitational or electromagnetic coupling capable of resonating with distant fields. In essence, the object may be interacting with Earth's ionosphere as a reflective medium, bouncing signal harmonics across our planet's own electromagnetic shell. A more radical theory, being quietly studied by researchers at the European Space Agency, proposes that the echo effect may not be traditional signaling at all. Instead, it could represent a kind of environmental probing, as if 3I Atlas were using atmospheric response as a form of remote mapping, similar to echolocation, to chart Earth's electromagnetic boundaries in preparation for something larger. The most unsettling possibility? That the atmosphere was never meant to detect the signal. We were simply in the path of something directed beyond us, toward another object, or perhaps something stationed within Earth's own orbit. But because of how our atmosphere functions as a reactive shell, we caught the reflection. Whether by accident or design, Earth responded, and something we don't yet understand, heard us echo back. At exactly 10:37 UTC, on the morning of November 29, 2025, the European Southern Observatory's SPHERE instrument, designed for high-contrast imaging of exoplanets, detected something both elegant and deeply confounding. While analysing scattered light from 3I Atlas using polarimetric filters, scientists observed a sudden and unexplained polarization inversion occurring at a very specific geometry, phase angle 37°. This moment would go on to redefine how we interpret light interaction with non-terrestrial materials. In astrophysics, polarization refers to the orientation of light waves as they scatter off surfaces or pass through materials. Normally, when light reflects off a comet's surface, it becomes linearly polarized, a standard phenomenon caused by interaction with dust grains or gas particles. This linear polarization usually increases gradually as the phase angle, the angle between the light source, the object, and the observer, increases. But 3I Atlas didn't follow that rule. For nearly 90 minutes, as it moved across a narrow viewing window near the Sun-Earth axis, the object exhibited predictable polarization behavior, until it crossed the 37-degree phase angle, at which point the polarization not only reversed in orientation, but changed type entirely. Instead of maintaining linear characteristics, the light became circularly polarized, and the handedness of the wave flipped from left to right within seconds. This was not only unnatural, it was active. Even more compelling was the fact that the inversion only occurred in specific wavelength bands, particularly in the near-infrared and deep violet spectrum. Visible light remained largely unaffected, suggesting that the inversion wasn't caused by surface reflectivity or natural scattering, but rather by frequency-dependent interaction, similar to phase-retarding plates used in optics labs to manipulate photon spin. In other words, 3i Atlas was behaving like a controlled optical device. To validate the results, a second observatory, Mauna Kea's polarimetric imaging system, was brought online with seconds to spare before the object moved out of viable view. It recorded identical inversion patterns at the same 37-degree angle. Even airborne instruments aboard NASA's SOFIA aircraft, which had been redeployed for emergency observations, recorded the exact same shift in polarization state, confirming that this was not an equipment error or a misalignment glitch. What made this even more extraordinary was that 37 degrees is not arbitrary. In electromagnetic theory, it corresponds closely with the critical Brewster angle for many synthetic surfaces, especially materials engineered to create zero reflection interfaces. On Earth, this is how stealth coatings and cloaking materials are designed, by forcing light to refract or cancel at mathematically precise angles. The fact that 3i Atlas displayed this behavior at the astronomical scale, across multiple energy bands, points toward engineered manipulation of photon behavior. Why would a comet, or an object shaped like 1, need to manipulate incoming and outgoing light at such a refined level? One possibility is directional masking. The object could be actively hiding part of its structure or internal emissions by rotating polarization fields, a tactic used in optical stealth systems. Another theory proposes a data gate, a threshold at which energy or information is only allowed to pass when the object crosses a precise spatial alignment. But the theory gaining the most traction behind closed doors is far more chilling. Researchers in quantum optics suggested that the circular polarization shift could act as a spatial handshake, a signal that confirms alignment with another field, structure, or observer. This type of polarization is often used in entangled photon systems, where orientation determines whether or not two systems are in resonance. The inversion at 37 degrees may have triggered a pairing event, not with Earth, but with something else entirely. Because immediately after the inversion, a cascade of smaller echoes appeared in the same frequency range, measured not from 3i Atlas, but from a point further beyond it, in deep solar orbit. In short, the polarization inversion may not have been a response to sunlight. It may have been a key, a signature pattern, meant to unlock the next step. By 11:09 UTC on the morning of November 29, 2025, researchers analysing composite scans from the James Webb Space Telescope, the Chandra X-ray Observatory, and the Atacama Large Millimeter Array, ALMA, detected something that didn't fit within any natural cometry model. Within the core region of 3i Atlas, beneath its irregular outer casing and below the plasma layer that had stabilised earlier that morning, flat, grid-like surfaces were beginning to emerge. These weren't cracks or fractures. They were planar structures that held their orientation through multiple rotations and scans. These internal planes, as they were quickly dubbed, were arranged orthogonally, at 90-degree angles to each other, and appeared to intersect deep within the core's central mass. The geometry, symmetry, and persistence of these lines across multiple imaging modes immediately ruled out natural crystallization, which typically forms radial or chaotic patterns. These planes were anchored, stable across different light wavelengths, and aligned with the object's own internal pulsing rhythm. This immediately raised the question, were we witnessing the formation of an internal framework? Thermal models showed that as the object cooled from its earlier phase shift, certain sections of the core remained hot, not in a radial pattern, but along specific flat surfaces. These hot surfaces absorbed and re-emitted infrared radiation in narrow bands, acting almost like heat mirrors, redirecting energy across consistent angles. Such behavior is not only non-natural, it mirrors terrestrial energy routing systems, such as those used in satellite heat management or optical laser cavities. In short, the planes weren't just present, they were functioning. Polarimetric filters revealed another surprise. When light passed through the outer layers of the object and hit these internal planes, it split into predictable polarizations. This means the surfaces weren't just reflecting or blocking light, they were modulating it, as if acting as waveguides or optical control gates. Further supporting this, magnetometer readings taken from Earth-orbiting satellites showed consistent periodic distortions in the background interplanetary magnetic field. These distortions pulsed outward in exact harmony with the internal structural formation seen by Webb and ALMA. That indicated the planes weren't isolated features, they were part of a larger system, likely interlinked, possibly designed for field projection or resonance coupling. But here's the detail that forced every scientific institution to pause. Each internal plane aligned perfectly with previously observed external anomalies. The UV-X pattern, the electromagnetic wake, the asymmetric plasma shell, and even the Lagrange point interference wavefronts. The geometry was nested, as if the entire body of 3i Atlas had been built around a hidden three-dimensional architecture that was only now becoming visible because of energy flow changes inside the object. And then came the most haunting discovery. Backtracing the projected angles of the internal planes, scientists at ESA's Optical Geometry Lab found that, when extended outward, 3 of the planes converged at a distant spatial coordinate, a specific region just beyond Earth's orbit. The convergence point wasn't random. It sat within a known gravitational lensing corridor, often used for deep space observations and, theoretically, long-range signal redirection. This alignment gave rise to a chilling hypothesis that the internal planes were not designed for support but for focus. They could be functioning like parabolic reflectors, aiming energy, information, or matter toward a very specific destination. The geometry, the convergence, the timing, it all suggested something intentional. Some called it a lens, others a transmission grid. A few began whispering terms like computational geometry or spatial compiler, ideas usually reserved for quantum architecture. But no matter the terminology, the conclusion was consistent. Something inside 3i Atlas was building itself into a configuration that implied targeting, transmission, or activation. And it wasn't random. It was aligned, perfectly, mathematically, and intentionally. Whatever these internal planes are, they are not structural leftovers from a broken comet. They are part of a blueprint. By 11:33 UTC on November 29, 2025, there was no breaking news alert, no televised press conference, and no emergency broadcast from NASA or the European Space Agency. And yet something fundamental had changed. It wasn't announced. It didn't need to be. You could feel it in the tone of internal memos, the silence between scientific teams, the subtle but irreversible edits made to public-facing reports. Across observatories, institutions, and research groups worldwide, a silent shift in consensus was taking root. For weeks, 3i Atlas had been framed publicly as an unusually active interstellar comet. That term, comet, served as a comfortable container, a linguistic barrier between scientists and the deeper implications of what was being observed. The thermal anomalies, the structured emissions, the lack of traditional outgassing, it could all be unusual yet still natural. But after the events of November 29th, that narrative no longer held. The shift didn't happen because of one singular discovery. It happened because of the cumulative weight of consistent impossibilities, a structure that maintained angular alignment across chaotic solar winds, pulses in the ionosphere without solar triggers, a polarization inversion at exactly 37 degrees, something that obeyed optical design, not astrophysical chaos, geometrically perfect internal planes that projected focus points across space, gravitational disturbances at Earth's Lagrange points, subcarrier frequencies riding on electromagnetic waves with prime-base spacing, a total absence of chaotic fragmentation. No one openly declared, "This isn't a comet." But behind the scenes, conversations began using different terminology. Instead of fragment mass, researchers began referring to modular configurations. Instead of outgassing, the term energy rerouting began appearing in documents. A shift from naturalistic language to engineered descriptors had begun, quietly, without ceremony. This evolution in language mirrored a deeper psychological shift, a breaking of inertia in the scientific mind. For decades, astronomers and astrophysicists have been trained to look for the simplest natural explanation. But 3I Atlas refused to cooperate. The object wasn't behaving like debris, it was behaving like a system. One of the clearest signs came from the cancellation of planned disintegration watch missions. NASA, ESA, and even Japan's JAXA had previously positioned telescopes and probes to monitor for structural collapse or tail ejection events. On November 29th, nearly all of these missions were either paused or redirected. The reason given? Structural coherence exceeds thresholds for long-term stability. A quiet way of saying, this object isn't falling apart. It's holding together better than any comet we've ever seen. Even more telling, collaborative agreements between traditionally siloed space agencies began forming. Agreements focused not on comet science, but on signal analysis, materials modeling, and multi-vector field mapping. In internal Slack channels, private emails, and encrypted research platforms, the word object replaced comet. The word program began appearing in speculative white papers, not as metaphor, but as potential reality. And yet, this shift didn't come with fanfare. It came with stillness. That stillness was the real indicator. Because when scientists stop talking, it's not because they have nothing to say, it's because they're suddenly aware of how much they don't know. On November 29th, the global scientific community stood at the edge of that realization. The comet that wasn't a comet had moved beyond anomaly. It had entered the realm of intentionality. The few researchers willing to voice what others only thought began asking different questions. What is this object doing? Why now? And is it waiting for something? The consensus hadn't just shifted from natural to unnatural, it had shifted from observation to implication. And while the public may not have noticed anything different that morning, the world's best minds had crossed a threshold. Not in knowledge, but in admission. For the first time, they weren't trying to explain what 3I Atlas was. They were preparing to respond to it.